Behind the beauty of nature lies a hidden problem that many of us overlook: waste cooking oil. Every day, thousands of liters are discarded after use, silently polluting our soil and water. Yet in a world striving for sustainability, what we see as waste may actually hold untapped potential. The main problem identified is pollution from used cooking oil and the use of toxic chemical in commercial shoe polish. At the same time, nature provides us with amazing raw materials like beeswax and shellac that can help us create sustainable solutions. That's why our team developed an eco-friendly shoe polish made from waste cooking oil, aiming to reduce pollution and promote green innovation. So here is our problem statement of this product. First, waste cooking oil has a lot of negative effects on the environment. Secondly, most commercial shoe polish products still rely on antibacterial agents. And lastly, limited research exists on the utilizations of waste cooking oil in shoe polish formulation. So let's go through about our objectives from the problem statement. First, to treat waste cooking oil through filtrations and pre-treatment process. Second, to formulate shoe polish from treated waste cooking oil with varying proportion of shellac and beeswax. And lastly, to conduct physical-chemical properties of formulated shoe polish in terms of viscosity, density, color, pH, and texture.
Today, I will present the method for developing a binding mixture utilizing waste cooking oil and chicken skin and analysis we conduct. This is our full methodology flowchart. We start with two main ingredients. For waste cooking oil, it undergoes pre-treatment using bleaching earth to purify and prepare it for formulation. For chicken skin, we do a wet rendering at temperature between 135 degrees Celsius and 140 degrees Celsius to extract fat suitable for the binding mixture. The binding mixture, waste cooking oil and chicken fat are combined and we mixing the binding fat with other ingredients. The table shows different percentage of beeswax and shellac for each formulation because both is our variable and the other ingredient is same percentage for each formulation. We conduct several analyses, like a viscosity measured using a 7 mm probe type and the instrument is viscometer. Next is texture assessed by evaluating the physical structure using a cylinder probe. The instrument is texture analyzer. For melting point, checking at which temperature the binding mixture start melting. The density determined by dividing each sample mass by its volume in cm. The last one is pH, measured with a pH meter to confirm suitability for intended applications. That's all for methodology.
For the pH result, all formulations were slightly acidic, ranging from 4.6 to 5.5, which is suitable for leather application. For formulation 1, containing 10% shellac and 10% beeswax, showed the most balanced pH of around 5.1, indicating good product stability and compatibility with leather surface. In the density analysis, formulation 1 also recorded the most consistent value, reflecting a uniform mixture between shellac, beeswax, and filter oil, which is contribute to smooth texture and even coating. For texture, formulation 1 display a semi-solid and smooth consistency, which make the polish easy to apply and provide a uniform glossy finish. In the melting point, for this formulation was found to be between 55 to 60 degrees Celsius, proving good temperature stability and preventing the product from melting or hardening under room condition. Lastly, in the viscosity analysis, formulation 1 achieved an optimal viscosity value approximately 63%, which fall within the ideal range of 50 to 17%, ensuring balanced flow and easy spreadability.
After we look at the result, now we move to the part discussion explanation. Now we move. The important discussion is a compass, the entirety of the result. Based on the result, we got the result medium A analysis. You can see here. Based on the result, we found is shallot and beeswax is equation proportion. Produce the most stable and producer formulation. This is likely pH acidity made it safe for application. While suitable density and viscosity ensure smooth application and uniform flows. The semi-solid texture and stable, melting point allow easy to use and good storage stability. This evaluate between hard and soft wax exchange performance. Overall, for formulation 1, this is the best formulation, the best overall formulation, showing excellent stability, usability, and finishing, while promoting sustainable of trade use cooking palm oil.
Generally, we can conclude that the best formulation of our developed shoe polish product is formulation 1. This is due to the formulation 1 have the stable and balanced composition between each shellac and beeswax, which is both have 10% composition. The problem statement and objective of our findings are being successfully achieved, outcome and outdone through the analysis result that are being discussed previously.
This is our final part in this video, which is we want to tell about our impact and contribution of this shoes polish product. So this is our impact and contribution for the shoes polish.
So, this is our impact and contributions, and based on this, we are quite confident that the product we are developing has its own sustainability and innovation.
This is achievement for our shoes polish product.
So the final part, our product show sustainable development goal, which is SDG 9. So that's all for us.